Okay, this is number 11 from the mock exam, so this is going to be implicit differentiation. And now we're going to have a product rule. Okay, now we're going to keep all dy dx terms on the left. Factor out a dy over dx. And then divide both sides by x minus 3. Okay, so this is dy over dx, but we need to figure out what that's equal to at the point 2, 1. Okay, so wherever there's an x, I'm going to put the 2. Where there's a y, I'm going to put 1. And we get 5, which was a. Okay, this is number 12, and you're given a function, and it's asking what is the rate that this is changing, so that's going to be the derivative. And then we need to know what's going to happen at t equals 3. Oops, sorry, mistake there. Hope you caught that. Should have been that. Be nice if I look at my notes. And then we get -6, and that was D. Okay, so this is number 13, and this is like the quiz we had the other day. So the only thing that's different is that you're given the slopes for all of them, not the original. So it doesn't really matter what the picture looks like, you know, for the original. So we're just going to try, I'm going to choose the point 0, 1, and I'm going to try that in all of them, and we'll see what happens. So for A, if I use 0, 1, I am going to get, and that will equal 0. If now look at your picture at the point 0, 1, and you will see it is a positive slope. So therefore, it cannot be A. So I'm going to keep a little running list here. Okay, so we know it's not A. Okay, next I'm going to use that same point, and I'm going to try it on B. Okay, so B is this. I'm going to substitute in 0, 1. And I get 3/4, and it is supposed to be a positive slope, so that's a possibility, so we're going to keep B in the running. Okay, let's try C. Okay, this is C. And I'll substitute in 0, 1. And it's 0, but it's supposed to be a positive slope, so therefore it can't be C, and we'll take that one out. And now we're going to check D. And I'll put 0, 1 in there. And this will give us 1, which is a positive slope, so D is a possibility. So we've narrowed it down to 2 possibilities, and now we'll try a different point. So next, I mean, you could try whatever point you want, but I tried -1, 1, and I'm going to try this in B, and this was B, and I'll get this. So that will give me 3/4. And if you look at the point -1, 1, you will see it's a positive slope, so B is still in the running. And then we're going to try D. And we'll substitute negative 1, 1 in there. And this gives us 3 over 4. So that D is still in the running. Okay, so we need to come up with a better plan, and I think what we need is a negative y value. So we're going to try at the point 1, negative 2. Okay, let's go back to B. Okay, this becomes a 6 on top, and this will give us negative 3, and that can't be because we need positive, so we'll take B out, and then we'll try D just to make sure. Substitute in. And you get 6, and that's positive, so therefore the answer is D. Okay, here's number 14. There's a lot of information going on. What we do know is that the derivative is equal to ky, and k is a constant. We know that when t equals 0, the weight was 120, and dy over dt was 24. That's at t equals 0. So they're asking for us to find the original function. So this is going to be a differential equation. We'll put ky over 1 and cross multiply. Okay, we can't mix the y with the t, so we can divide both sides by ky. I mean, k is a constant. You could have just left it. Doesn't really matter. I brought it over. And you'll get that. Okay, then we're going to do an integral of each side. And since k is a constant, I'm going to bring that out to the front of the integral. So there's just less for me to deal with. Okay, and now I'll take the antiderivative. The antiderivative of 1 over y is ln y. And the antiderivative of dt is just going to be t plus c. Okay, so if we multiply both sides by k, because remember we want to get y alone, then the left side will just get ln y, and on the right side we multiply every term by k, so we'll get kt plus, now if we multiply c times k, it's just a constant times a constant, and it becomes just yet one more constant. Okay, so we're making some progress here. Okay, and then we want to solve for c. So we know that when t equals 0, the whole thing is 120. So ln of 120 will equal k times 0 plus c, and therefore c must equal ln of 120. Okay, so let's just erase this up to here, because now I'm going to substitute into this. And so now I know that ln of y equals kt plus ln 120. Okay, let's make some room. Remember, we're supposed to be solving for y. Okay, so we're going to add a base of e to both sides. Oops, it's a little bit messy. Okay, that's a base of e to both sides. So remember, there's a rule that says if you have a base of e and a base of e, the whole thing just equals y. And then it would make our life a little bit easier if we broke up the right side to this. okay? Because if the bases are the same, you keep the base and you add the exponents. Now we can simplify a little bit more. So this is that same rule, base of e, the whole thing equals 120. Okay, let's make some room. Okay, so I'm just going to rewrite this up here a little bit nicer. Get rid of that. Okay, now, thing is that you can't have k in there. We have to get rid of the k. So what is the only thing that, well, we didn't use yet? We did not use this 24, and they never give you anything for no reason. So if you go back to the original, this was dy over dt, and when the derivative was 24, we get k times 120. So divide both sides by 120, and you get 24 over 120, which is equal to 1/5. So now I'm going to rewrite this, and that was B. So you can see that was quite time consuming, and this is a question that you might decide to come back to if you have time, and if you don't have time, then you're just not going to do that one. Okay, and finally here's number 15. So we have graphs of f and g, and we're trying to find which is false. Okay, so let's look at A, and it's talking about f of x. So we're going to look at the f graph and look at the limit as x approaches 1. And as x is approaching 1 from the left and the right, the limit will be 0, even though there's an open hole because it's just approaching it. And that's what A is, so that's true. A is true, and we want false, so A is out. Okay, let's look at B. B says this. Okay, let's look at the graph of G, and the limit as x approaches 2 from the left side is 1, from the right side it's -1, therefore it does not exist, and this one is also true, so therefore B is out because we're looking for the one that is false. Okay, let's go to C. Okay, so let's try, this looks a little confusing, but we can just try substitution. That's what we always try first with limit problems. So we can substitute 1 into f of x, so it's f of 1, and then g of 1 plus 1, which is f of 1 times g of 2. Okay, so look at the graph, and f of 1, so when x is 1, what is y, and there is nothing there. It doesn't exist. Okay, and g of 2 is 1. Okay, so for C, oops, sorry, I should look at my notes before. And just so you're not worried, I did check all my answers against College Board's answers. I'm sorry, if you look at f of 1, I'm making a mistake students make all the time. When I said it doesn't exist, there's an open hole there, but if you look straight up the graph, then you can see that there's a dark black circle there, and f of 1 is actually equal to 2. So this is 2. So we get 2 times 1, and that equals 2. But C said it doesn't exist. So it looks like C is going to be the winner, but let's just keep going to just double check D. And D says this. Okay, let's do substitution again. So we'll get 1 plus 1. Oh, this started as g of x times g of 1. So this is f of 2 times g of 1. Okay, so f of 2, it looks like it's going to be a -1. And g of 1 is going to be 1, and this gives us -1. And it said it exists, and yes, that is true. So we're looking for false, and that's why C is the winner. Okay, so that was 11 through 15.